Grab nicely.
Okay.
Fucking love you, my diz. All right. I think we are. It's about set. So welcome. Good day. Good morning. Happy Saturday. This one up. How's it going, Tyeth? So good morning and welcome. First of all, thanks to everybody who's watching. For anybody that might be new, my name is Tim. I go by Foamy Guy on GitHub and Discord. I typically work on CircuitPython stuff on these streams, which occur weekly on Saturday mornings at around 10 a.m. Central Time. We're a few minutes early this morning. I've been kicking it off a little bit early the last couple of weeks just because I've been up and ready to go and was working on stuff anyway, so I just popped the stream on. Today we are a few minutes early, but not really as much as the last couple of weeks. In any case, around 10 a.m. Central Time is when I typically start streaming on Saturdays, and usually I'll be working on something related to CircuitPython. If you don't know anything about CircuitPython, you can learn more about it on the main website for the project here, which is circuitpython.org. Basically, this is a version of Python that runs on tiny computers called microcontrollers, and this allows you to, most typically what it does is it allows these devices to plug into the computer with a USB cable and then show up like a thumb drive, and then you can edit some Python code on that thumb drive, and then the microcontroller, the computer that's inside the chip on these devices, will actually execute that Python code for you. And CircuitPython is the program, the project that allows it to interpret and execute that Python code. Today, we are working on cutting edge, brand spanking new stuff. In fact, I don't even think this is in here yet. So M5 is a company or entity. I don't really know. Oh, it is actually listed here. Interesting. I guess it gets listed as an unknown as soon as it gets merged. I was thinking it would have to be added to the .org first, but M5 is a company or an entity that makes some of these microcontroller devices. They tend to be more like finished, basically. They tend to like have boxes and stuff. They tend to be more kind of all-in-one units that serve a particular purpose. I mean, there are, well, this is not M5, this is Alorum. So yeah, M5Stack, it looks like, you know, pretty much all of them are in a little box, which is not necessarily typical of a lot of microcontrollers. It's just a bare board, right? So M5 Cardputer, though, is the device I have right now, which it turns out is listed in here, but doesn't have a picture yet, and it's like, it looks like it's probably just unknown stuff. It doesn't have like anything for it yet. No builds or anything. So this was just merged the other day. Hug report to James J. Nadeau, which is who started this. And I did the last couple of bits that it was waiting on in order to get merged. And then we got this merged the other day, which is really cool. So this device, I'll pull that up as well. M5. Is it M5Stack? I don't actually know. So I mean, this thing in front of me doesn't say stack. I don't know if it's actually like, okay, yeah, M5Stack I think is the company though. Right, because that's M5Stack.com. I think their original product was meant to like kind of feather, you know, in the similar vein as feathers or metros, kind of like you could stack them, but with stacking headers or whatever. They make all kinds of stuff these days though, so the name doesn't necessarily fit. In this case, it's like an all-in-one little computer, basically. It's got a tiny little screen, it's got a keyboard, it has a ESP32S3, which is the main brain for it, that's plugged in there in the corner. It's got a microphone, a speaker, an IR blaster, which is kind of cool. Not a thing you see on a whole lot of devices these days. Little IR for being able to send like TV remote signals and stuff like that. It's got a nice big chunky battery built into the backing thing, so you can kind of like wander around with it out in the world and type stuff on it, which is pretty cool. The ESP32S3 obviously gives it the access to Wi-Fi, so it can reach out to the internet and do stuff. It's got a micro SD card slot. It's got a lot of cool stuff. So neat little all-in-one device. Just very, very, very brand new support for CircuitPython though. If you have this device, there's lots of support for lots of other ways to program it and things you can do on it, and those are going to be a lot more fully featured and ready to go than CircuitPython is at this point. But CircuitPython is what I am working on this particular device, and even more specifically where I'm at is I am going to try to mock out the way that the keypad module could work for keyboards like this one. So is there a picture of the back of it on here? I actually noticed on the back it's got a pretty good graphic. All right, bigger, enhance. Okay. So the keyboard is a key matrix of 8 by 7, so it's got 56 keys, but there's a trick to it. It's not just straight up 8 by 7. The 8, which are the rows in this case, the 8 rows, 0 through 7, those rows are not all on their own pins. Instead, they are on a shift register, a 74HC whatever, 138 I guess is what it says right there. It's a shift register that basically makes it so that we have 3 input pins, which happens to be A1, A0, and A2. And those 3 input pins actually get, multiplexed or whatever, shift registered, and turned into 8 output pins, which are the rows of this key matrix. So in CircuitPython, normally the way that you would do key matrices, that would ordinarily be the keypad module. Was that faster than usual? That felt really fast for the search. Usually the search I feel is kind of slow. The keypad module is ordinarily how you would do this. You kind of like give it the row pins, you give it the column pins, and then these are just helper classes. Key matrix right here is the real meat of this. So you would give it the row pins, you would give it the column pins, a couple other configuration details like how it behaves up or down anodes, things like these, interval, how often do you want to check, max events, I don't know, I guess that probably affects RAM or something. And then you would call events, which is a property, that would give you back a list, which might be none if no keys were pressed, or empty or something like that. But when keys are pressed, it would be a list of these, well, it'd be a queue, I guess, event queue. It would be the queue of these event objects. You can then go over those event objects and see which key number each one was, whether they were pressed or released, all that kind of stuff. And there is a shift register keys, but this is a different kind of shift register. This is for a shift register that has like latch and data and clock, which is more like kind of serial, I think. It's kind of like SPY in a way, I think. I don't actually know for sure. That's what I think. Whereas what we have is still a shift register, I think. It's still technically considered a shift register, but it doesn't work with like a data pin and a sequence pin and a latch pin. Wait, no, not sequence. Data, clock, and latch. It doesn't work with those. It just works with 3 inputs. Those 3 inputs, like in my mind, the way I think of it, they get converted to binary, basically. So like we have 3 bits of binary, which gives you 8, numbers as output, because that's how many things you can output with 3 bits of binary. I mean to ask, what microphone do you use? Sound is really clear. Yeah, thank you. I use it's called, I think, Yoo-Hoo which is kind of a weird name. I will say it's not particularly special. It's just from Amazon. I think it was around maybe $60 or $70 or something like that, with the ARM and everything included. I do not know the model number. I could try to look up the model number at some point, but it was basically just this kind of deal from Amazon, basically. Might be this one. Is it silver under there? I don't want to mess with it. It might be loud. Sorry. I have the desk clampy one. I think a lot of it is being able to have it clamped and like pulled. Like, I don't. Where's my camera preview? So the microphone is like. I actually thought it would get into frame. Oh, it did. It's just really hard to see because it's on a black background. You have a. Oops. Dark mode is. Okay. Anyway. Microphone is like right there, which is basically pretty much right off camera, but still right in front of my face pretty much. And it's directional as well, which is nice. And I have it kind of angled to where it's pointed right at my mouth, which I think does a lot of the heavy lifting of making it sound pretty good. Okay, so we have shift register keys. This is how we would do it if we had like data, clock, and latch, but we don't. We have a different kind of shift register. We have a what did that say? 138? Yeah, we have a 74HC 138 as opposed to a 74HC 165, which is obviously way different. But the end result is similar in that we have 3 inputs and, well, in our case, we have 8 outputs. I don't know. This one might be able to have more. So we don't have a class for that. So what I want to do, like, I don't have confidence that I could just jump right into the C code and like make a version of this that is for the 138, was it? Yeah, 138 shift register. I don't really think that I can just do that very easily, or perhaps at all, without a long struggle. What I can do, though, is I can write out the Python code for it. So I can make a Python class that behaves very, very similarly to the Keypad module, and I can make it work with the 74HC 138 shift register, and I can mock out like how it could behave, and then I can hope that somebody else will put it into the core, or once I have a Python implementation to look at, that might help bridge the gap to get it to where it is within reach for me inside the core to actually be able to do it. But to just write it out off the cuff without anything to reference other than the other shift register class, I don't necessarily think I could do. But maybe if I have Python code. So that's where we're starting. We're writing the Python code that mimics Keypad, just so we can kind of like mock out the API a little bit, how it could behave. How's it going, DJ Devin? Coffee time. Coffee cheers. I have a road clamp to the desk, but I need another one for the other computer. I gotcha. And I have some of this done. In fact, I have kind of some of this done, basically. I'll show you what I have here. What is the code in this right now? So this is web server stuff. I'll save that out. Eventually we are going to go maybe potentially back to web server stuff. We'll see. Okay. I don't think I cleaned this up. Are these used? I don't think these should be used at this point. I'm surprised it's not yellow. The only usage in all places. Usually it will like yellow, like warning highlight it. Okay, I don't have the stubs turned on right now. We'd have to like build a custom one if we wanted to get this device anyway, because it's brand new. So the way I have this set up right now, I have the row pins, I have the column pins, I created 2 list objects to hold the digital in-out objects for the rows and the columns. I created a tuple that holds the masks, the bit masks for like each of the 3 digits in the 3 bits of binary that we're gonna have, because we're gonna use some binary comparison. I don't know the right name of the operator that I'll be using, but it uses these and it's cool. It's convenient. We initialize the SD card. That's just a test though. I was not really needing that for something. We can take that back out, in fact. Does that happen inside of code web server stuff? No, but let's dump it there just for the heck of it. Okay, so we don't need that. So we have set state tuple. That's old. Let's delete that. We have set state. Set state takes state binary, which is a number, an integer, which we are treating as its binary component. We are, or its binary representation, I should say. So that number, it's always going to be between 0 and 7. We're effectively kind of like treating it as its binary sequence. We're going through all these possible bit masks here, all these compares, and then we're comparing each one to the current index within the state binary value. So we're going through each one of those 3 bits, 0 or 1. We're saying if the current one is 1, then we want to turn a particular row's digital in-out pin on. So like, you know, state binary, that's going to be a number. Let's say it's the number 5, for instance. So the binary representation of 5 is a 1, 0, 1. We have a 1 in the 4s column, then a 0, then a 1 in the 1s column. So 1, 0, 1 for 5. We basically will be comparing with these bit masks right here. So we're going to compare the first columns right there, the 1s. We're doing that AND thing. So we have a 1 here, we have a 1 here, which means they're both true. So we're going to turn on the row 1 or row 0 if you want to be 0 indexed. The 0 index row pin, we're going to turn that on. Then we look at the next one there, compare it with this. Well, 0 in this one means they're not both 1, which means we don't turn this on. We look at the last one, we compare that with that one. They're both 1. That means we turn on index number 2 row pin. So this takes our binary number and it sets our row pins based on this pattern of the binary inside of whatever number was passed to it. We initialize these pins. We initialize the column pins. Columns are inputs, rows are outputs. Scan keys, this is old. Let's delete that. Sorry, I'm doing my cleanup as I'm like showing you what this does, which is maybe makes it a little bit more confusing, but I didn't do my cleanup before. So inside scan keys, we have a loop 0 to 7. We call set state on I, so that's what's up here. That's the one we talked about before. That's going to set all of our row pins based on the current number that we're on. It's binary representation. Then we're going to go through the columns, and we are going to check and see if in this case, if the value is low, which means that the button has connected the pin to ground, which means that it's pressed. And then we just print this thing that says it's pressed. And then main loop down here, while true, just call scan keys. We don't need this part anymore because that was for the SD card, which I just pasted into this script because it happened to be my CodePy and I needed to test the SD card. I should have made a different one, but I didn't. But now it's gone, so we're good. All right, delete this too. Oh, let's make sure this is working. Basically, all this will do is just print the information about which key is getting pressed. And then that gets all of you, the viewers, caught up to where I am at on this project. And I will start kind of doing what I'm wanting to do next. So each time we press one of these buttons, this thing tells us which button got pressed. but it doesn't know, like, you know, the control button or the option button or the alt or the Z. Like, it doesn't know all of that stuff. It just knows the number right now. So we want to take that and we want to mold it into something a little closer to shift register keys, which I will call, I don't know. I'll probably just pick a random name. I mean, it's not random, but it's kind of weird because we already have shift register keys, but we are also using a shift register. So it's like also shift register keys, just a different kind of shift register. Maybe there's a name for that. Maybe there's a name for that. Let's try to see if Edge GPT can explain that to us very, very, very briefly. Can you tell me the difference in types between 74HC165 and 74HC138 shift registers? Do we feel lucky? I don't want like 8-bit parallel load. Okay, that is exactly what I want. First bullet point. Thank you. Thank you, friend. I appreciate it. So, 165, that's an 8-bit parallel load shift. 8-bit parallel load shift register. The 138 is a 3 to 8 line decoder demultiplexer. Okay. Let's call it multiplex. Let's call it multiplex keys. Multiplexer keys? Let's call it multiplexer keys, because that's shift register. Multiplexer. Okay, we're basically going to take the multiplexed row pins, the column pins, key count? What does that do? Number of data lines? Okay, no, we don't have that. Value when pressed, let's pass that to came in late, so we were around a bit to see what you're working on. Cardputer looks really cool. Yeah, I agree. Interesting way of doing key matrix shift registers that doesn't look easy to track. It was easier than I thought. It was easier than I thought it was going to be, honestly. Guessing the key matrix should track it automatically with a bit of configuration. I never heard of a demultiplexer. I never heard that term necessarily either. So I mean, key matrix, like ultimately I would like to get it into the core where it can handle this, but it's not in there right now. So my hope is that by writing Python code, we'll be helping in some way down the road of getting it into the core, whether it's helping myself be able to actually wrap my head around it or helping somebody else discuss the API and decide how it should be and then implement it or whatever. But we're not going to do this. We're not going to do interval because one difference is that these keypad things, these actually are working in the background to read the keys, and we don't have the ability to do that from Python code. So we're not going to have an interval. The interval is however fast you call like the scan function, which is actually a property called events, I think. Max events, I guess we can do that. Max events, we might as well. Nah, do we need to? I don't think we need that either, actually, honestly, because this really only matters when you're doing it in the background, because when it's in the foreground, like, I mean, I guess we could have a max one, but we don't know which ones came first, right? So it's not really a queue anymore if you have max events, if you aren't in the background, since we're not going in the true order that they were pressed in. How's it going, Axel, my friend? So let's leave that one out. Latch, we don't need that thing. Keys, we don't need. We should. Wasn't there a value when pressed? we have? Okay, well, I think that's all. I think that might be all we need to start with. Oh, I just did all of this completely wrong, didn't I? Stuff does not go here at all. Wonder this thing is all mad. There we go. Self dot. I'm just gonna call it row pins internally. I am gonna make, actually, can I just use the event queue and the event objects? That would be super convenient if I could just use those, actually. Can I just instantiate one of these and use it without, like, using the shift pad thing? Event queue, keypad? Whoops. Can't create instances. Oh, red. All right. Oh, nice. All right, so we make a class for that as well. But it's super easy because we have list and it's basically a list. In fact, it might, could you just like literally, can we just literally use a list and not have a class? Because list has pop and append, and that basically makes it to where it can be used as a queue. Is that true? Oops. Pop. That removed the last one. But you can call pop index, I think. That removes the first one. And then append puts it at the end. So if we always append to the end, how's it going, Negvorsa on Twitch? If we always append to the end and then pop from the beginning, then it's basically a queue, and we don't really need a class for that. We do want self.events. I'll make it private, air quotes, private. And then we'll make a property for that as well, because there's going to be a little bit more logic we want when it gets called. Def property. Okay. We're gonna call self dot scan, which is basically gonna be this. And then instead of just printing this stuff, project summary. I don't know how much, if you've ever seen me or anything I work on before, but I'll try to give you the super quick version. So the main kind of like high level project that I typically work on streams is CircuitPython, which is right here. You can learn more at circuitpython.org. Specifically, we are working on this M5Stack Cardputer device, which has just very, very recently, within the last couple of days, gained support for CircuitPython. And we are trying to read the keys from the keyboard. And to be more specific, we're not just trying to read them, we're trying to read them and do it with a class that behaves kind of similarly to the official way that's inside the core, so that it can be used as a reference for hopefully eventually adding this capability to the core, because the way the pins are wired up is different than what the existing key matrix scanning inside of CircuitPython supports. Let me know if some or all of that does or doesn't make sense. I can try to elaborate. further or into any particular parts if you have interest. Didn't know you could work with lists like that. You make it look so easy. I'm used to display or remove and append. Is display basically just a list that we're working with? So things like pop and append or translate it into display. Learning something new. Thank you. Yeah, for sure. So display IO, I assume you mean group when you say like, is it like a list? Display IO group, it is a lot like list. I don't know if it's literally exactly a list. I know it used to be different. It used to not be as much like list. Like you used to have a max items, I think it was called, basically, where you couldn't add more than however many items you declared at the beginning. But now you can just keep adding more and more and more because it behaves more like a list these days. I'm pretty sure you can use pop and remove and all those things, but I'm not 100% certain with group. I think you can. M5 MCU, yeah. M5Stack is the name of the company, and then M5 Cardputer is the device that I'm working on right there. So I think I'm also not, well, can I create a key event? Oh, wait, where's event? Is it just event? Maybe it's just event. I think it is. I can make an event. Event has key number, pressed, released, and timestamp. Yeah, let's do that. Is there a constructor? Yes. Okay. So let's say event equals event keypad.event. Yes, you can use pop, remove a pen because I use them so regularly with display. That helped me translate the whole concept to list. I gotcha. I'm with you now. Yeah. Yeah, it's nice. I'll say Python is really nice about like when you find a thing that behaves like a thing you're used to, it suddenly kind of just opens this whole world of like, what? You can do that with that? I do have that experience a lot with Python, of finding a new thing and using it as its own thing, but then later figuring out that it's a more general. We can pass these. So key number we'll say is keynum. We're already calculating that. Do we need anything else? So pressed. I'm just going to say pressed is true. We're not going to bother right now with pressed false because it doesn't make any sense, right? Because these are events, and like we won't know. Like we can't make an event for when it gets released because we're not doing our stuff in the background really. The real keypad in the core will be doing it in the background, and it can have a pressed false just like the existing one does, but ours cannot do that very easily. We could use debouncer, I guess, internally. Technically, we should be checking value when pressed. But instead of this, let's say if column pin equals self.value when pressed. I'll default that to false, since it happens to be false in my case, and I'm writing the code, therefore I get to pick the defaults. Like timestamp, we can't really do. I mean, I guess we can, but it's not very useful if I'm honest, because again, it's the same problem, right? We don't know when the key was pressed. We just know that it is pressed right now when we're looking at it, right? It's different than the paradigm of when it's done internally. How's it going, Paul SK? Good morning, my friend. Yeah, no timeouts, and then, or timestamps rather. Press, we already have key numbers, so that's everything. All right. So we're going to take that event, we're going to put it onto the queue, which is our events. We're going to say self.events. We want to append this one the end. So that's going to put them all in the end. Okay, events, that's going to give you back a list of all those events. I guess, should we like, we need to remove them, huh? We need to like, after you call events, it should clear them out. How do we do that? That's awkward. I think... we need to make a copy of it, I guess. Yeah, because we need to like have a copy and then... Or... Okay, here we go. How about we do it here? How about at the beginning of scan? The beginning of scan, we empty out events. Does that make any sense? I think that's close enough. I think that kind of works for our case. Each time you call scan, which scan gets called by events. So we call scan, we empty out the events, we read all the current events into it, we return those to the code that called events, and then presumably it's going to loop around and call events again, the next iteration of the main loop, which will then clear out the old events after they've already been dealt with. DNet's got some pretty big on making people aware of using DNet. DNet what? The, not sure what you mean. The pins or something? M5Stack Cardputer, getting the keyboard matrix to work as it's not standard. Yep, exactly right. Yeah, thanks for putting that in the chat there for them as well. I was just able to build CircuitPython 9 RC0 for the Lawlin S3 Pro. Interesting. Scott suggested me to create a Pro. Oh, create a PR to have this board added. However, I just had a one-time experience to create the PR. I gotcha. Yeah, I mean, there's usually plenty of folks willing to help out. So I'd say if it's like something you want to, if it's something you're interested in, I'd say go for it. Add it, we'll get you helped out, to whatever extent's needed for sure. Cool, popular hardware and well-documented schematic. Yep, yeah, that's a neat open source thing. I was actually just staring at the back of it the other day. Once I got it, I just started playing with it. I didn't really look too much at it, but I just had it flipped over looking at the back the other day, and I was admiring how well the back is like self-documenting. It tells you a lot of information about how stuff is connected on the back to free resources. I never seen DNet above my head. I gotcha. I think we don't really need to free them. Or I mean, we want to free it, I guess. I think this will work for our case. We don't need to I don't think we need to necessarily clear it out all the way. We just want to make it so that if you call events multiple times, you don't end up with a list that's like 1,000 things long or something. We want to keep it to where events always only has, theoretically, it should have a maximum of 8 things. That's not true. It should have a maximum of 56 things, which is much higher, but it is the maximum. So the way we're writing it here is basically we can have one event per key, but we can't add a second event for the same key because it'll get cleared out. Which is not how the core one behaves. The core one does allow that, but again, the key difference is the core one is able to actually do stuff in the background, whereas I am not in this one. We could async IO it, but the core one doesn't use async IO, and I'm mostly trying to mimic the API. Not the functionality, but the API. That way, it's easier to translate into core code, hopefully. This feels ready to test, right? I think so. Right now, we're doing this kind of stuff. I think what we would do is we would say, matrix equals multiplexer keys, and then we would give that our row pins. We should probably make these named, maybe? Does it matter? Well, this is multiplexed row pins. And this actually needs to be digital in-outs, not... Oh, wait. Wait. when you create a keypad key matrix, does it take digital in outs or does it take, no, it takes board, right? We need to move this into the initializer. Yeah, it takes tuples of board pins. So we need to say, we actually need to put these into the initializer. But should also put them on like self. Okay, there we go. So now we're gonna have that on self. Okay, that should be self also. Set state. Where's this should be self also here. I see, but let's put that in, I guess. Oops. I'll call self set state. We should give this a better name. Set multiplexed state? Set multiplexed row state? Set multiplexer state. I'm gonna turn that off for now because we're gonna add print down here in a minute. Okay. So we have row pins, column pins, those are now ready. Row pins, column pins. Oh, we should be doing self here, although it doesn't actually, it's not gonna make a difference, but feels more correct. Can get rid of this. Literally just use that if events great, yeah, reset. Just use that last night for the first time. The board uptime is more than 24 hours. Just reset the board. Helps keep. Yeah, that's true. Yeah, I had a similar project where it was like a long running thing, and I would have it reboot. I had it reboot like if anything goes wrong, but also even if it's just like, hey, I've been running for a full day and nothing has gone wrong. It's like, go ahead and reboot now, just in case. Mine was on the feather, or not a feather, but a e-ink. What do they call that thing? I'm looking at one. Inky frame. That's the name. Inky frame. Okay, so matrix. I will leave the default on value when pressed. So then basically we'd be saying here events equals matrix dot events, and then we could say if events, and then we could say for event in events, and then we can print event. We put an underscore on for some reason. All right, I think that is enough to make it work. Okay, it did not crash, which is a good sign. I think I like it the other way, right? Uh-oh, key number's broken. Just always says key number 0. Oh, uh-oh, doesn't. The key number is currently being based on the column. The key number is currently actually the column. Probably need to change something to self. Yeah, this right here should be self. And yeah, that's probably enough. There we go. Got an accidental multiply by 0 or something going on there. Okay. Okay. I think this is enough of the behavior, honestly. I think multiplexer keys with this behavior is close enough to keypad. Like, the API is effectively the same. So I think this serves as a good kind of launch point. I can submit, I'll probably start with an issue because I don't have any code yet. So I'll probably submit an issue. I mean, I don't have any core code, I should say. Obviously, we have Python code. I'll submit an issue on the core repo, though. I'll put this Python code in there, and I'll kind of lay it out as like a proposal for how, what did we see those were called? Demultiplexed or whatever? Oh, where did my answer go? My answer is gone. My points? I don't care about my points. Give me my answer back. Bro, that's weird. I don't know. Okay, well, it's gone. In that case, I don't really have a need for Edge right now, so I guess I'll close it. Yeah, demultiplexed or whatever that thing said. There was another word for it too, but multiplex was the one I latched onto. Didn't spot in the code. Oh, Black Kitty's in the backyard. Whoa, Black Kitty. Didn't spot in the code. Why so many events for one press? Because we don't have any because we don't have debouncing. Is it per? Right now it's just as fast as you call it. Yeah, if we want to debounce, I mean this is the way Keypad works too, though, right? Like, if you call it super fast, you could get. Is that true? No, that's not true. It does debouncing, doesn't it? Does it? I think it does debouncing, actually. Does it do? I don't know. I don't know. The answer to your question, though, is because we're not debouncing. That's why we get so many. We're not debouncing. So I'm pushing the button, and it's staying down. And like this code right here, this is running really, 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 really fast. So by the time I press the button and release it, that has done a lot of loops. I don't know if Keypad not multiplexes, but debounces. I don't think it, off the top of my head, I don't think it does. We should find out, though, because if it does, then we should make this one behave the same. I'm just gonna make a keypad key matrix, even though it won't work like actually work for reading correctly. It will let me read like each pin will read something. It just won't read the right thing, basically. Columns to anodes? Is columns to anodes effectively determining the value when pressed? Let's try this. Event queue is not iterable. Oh, we're supposed to call it get. I didn't call it get. Should we add the get? I don't know. Is get the whole queue? Why is there a get? That's weird, actually. Event queue is not iterable. This is just printing. Why would a queue be not iterable? Just me, or does that seem kind of weird? Oh, I shouldn't have done that. I just pressed restart accidentally. The reset button is up here. No, it does debouncing. Not all of these are going to work, but... But we don't have released, so we can't really do debouncing in the same way, unfortunately. Does the queue clear when read? Yes. Well, sort of. Technically, it clears when you read it again. Yeah. So at the beginning of scan right now, it clears. Yeah, it does. Turns out it does have the debouncing, but we can't really do it because we don't. We can't really do the release very easily. And I'd suggest the keys have built-in LEDs. Oh, interesting. No, I don't. I mean, they may have that, but I don't think Keypad does anything with LEDs. I think if you had those, they would need to be... It would need to be hooked up to other pins. I don't actually know, though. See what it says here. Columns to anodes. Diodes. Yeah, I don't really know what that means. I mean, I can gather it's about where you've connected your stuff, but... Does it, I guess the main thing I don't know about it is if you just flip that value, will you start seeing true instead of false and false instead of true? Or if you flip that value, will it just not work at all? Because we have that like value when pressed, which you could basically just flip that and then effectively your logic would be reversed anytime you access the pressed or not. Yeah, I don't think I want to add the debouncing. I don't really want to write all the logic for it, because at the end of the day, I want it to exist in the core anyway, right? And then it will just, it won't just exist, so it'll need to get written in the core, but maybe that makes it worthwhile to do, I guess. It's awkward with the way we can't do the releases, though. Probably wouldn't work. It's weird. I wonder why the other one has values when pressed. I guess it's just because it's only for the shift register? Couldn't you wire your key matrix to be the other way, though? Guess not. Okay. One thing I do want to do, though, I don't want to do the debouncing inside of here right now, but what I do want to do is build another layer on top of this, which can be more like Cardputer library, which is where I do think the debouncing can take place. Because I do want to, like, the purpose of this was to be able to propose it as an API or a functionality for the core to be able to handle these multiplexed key matrices. But I would also like to just make something else out of this Cardputer. Computer helper. Let's just call it Cardputer, I guess. Hold on, I should save a copy of this before I get too far here. That's enough. That's enough for the core keypad proposal, I think. And here we're going to go on to actually try to make something else with this thing. Many different ways to diode matrix. In this case, it's using shift register with the diode matrix. Maybe a right and wrong direction. Gotcha. So we will take this. All right, I will. Okay. So we have shift to worry about here. So this part, I'm a little less decided on how the API should look. This is going to use the thing we made a minute ago. We know, I guess, that it starts like this. But instead of just printing the events, we're going to want to do some other stuff. So one thing that we need is a lookup table of the key numbers to the actual key that they represent. I'm going to make it a dictionary, but eventually we could change it to be a list. But a dictionary is going to be a lot easier to write the code for. And unfortunately, this is going to be a bit of just manual. Three, four, five, 6, 7. 7 columns, 8 rows. All right, and then it's going to end up in a super weird order to start with. I guess I shouldn't be doing this in CodePy. What? No, why would I not want a Python? Come on. Okay, let me actually get back to this one. So we need one of these that works in order to be able to fill in all these numbers. It's not running. Okay, that is 49. So 49 is tilde and tick mark. Yeah. I think I don't even know how I'm gonna handle. Okay, let's make these tuples. So unfortunately, now that I've already duplicated everything, it's all wrong. So 49 is tick mark, tilde, escape. I probably don't want this to actually be 7 anymore, though, so our nice grid is gone. 2D array row call. Kind of, yeah, but we don't. The problem is the order doesn't match the order of the keyboard, and if I use lists, then I need to, like, have a bunch of dummy items filled in so that I can get to the right index. And I don't want to do that, so I'm just doing a dictionary. When providing board image for CircuitPython.org, board template, do you just put one in original size folder, or do you need to provide large, small images? I do not know. I would say check the guide for adding a board to CircuitPython.org. It should hopefully say in there, but I don't know for sure. I've never actually added one. I'm pretty like I think there's like an actions or something that does those shrinks, but I don't I don't know for sure how to trigger it or if that's actually real. Should be in the guide though. If there is adding a board to CircuitPython, there should be like a .org section of that guide, I would think, and it should say on there. So if that page exists but doesn't say, then maybe mention something in the main channel, because we should probably add that. So 49 was those things. I should empty these out so that I have a good one to copy. Why are these white? Oh, because I broke it by taking the 49 out. There's a guide. I know for sure there's a guide for like adding it to the core. And I think there should be a page in that guide for the .org, specifically adding it to circuitpython.org. So 21, that is tab. We're actually just going to say tab. Actually, we could give it one of those, I think. .35 is function. So some of these have multiple things and some of them don't. This needs to have this though, otherwise it won't be a tuple. Seven for control. .42 is 1. So we could eventually, once I have this dictionary, we could actually write some Python code that will turn it into a list. So that's 1 and it's exclamation point. So what I'm thinking here is the first index, the 0 index, will be the literal character, if it's a literal character, and then the second, the index number 1 will be the shift version, and then if there is an index number 3, that will be the function version of that key. But not all the keys have all of those, so some of them will only have 2. And like delete right here will need a none in its shift version. Or maybe its shift version will just be the same thing as its regular version or something. It does feel like maybe we should switch and do rows now. It's awkward because I just did a column first, but I almost think we should just count rows now because we have the number 1. Like it feels like we should just count across now. So that is 50. So actually the vast majority of these have 2 instead of 3. I'm going to delete the third. .43. .51. So there is a pattern to this. It should be 44 next, I think. Yep. Databoard.org, you'll need you need 3 sizes of the same image: small, medium, large. Okay, yeah, looks like you got to do all 3. It is weird. We should make a script maybe that does it. It would be nice. Okay, I mean, it feels like you could do it with PIL. You just give it the biggest one and then it spits out small and medium or something. That'd be nice. Okay, so 5, 6. 52. Seven, gonna be what, 45, I think, yeah. That should be 53. Nine. Paren. Ooh. Oh wait, no, 0 paren. There we go. Okay. Get ahead of ourselves though. 9 is 46. Then 54. Then 47. And I don't know. To my eye, it actually looks like the underscore is the default one and the hyphen is the shift one. Which is backwards from a lot of keyboards, but the main one looks wider, which typically like an underscore is wider than a hyphen. Also, it's at the bottom of, you know, like the number here. So like that looks underscore-ish. It's not in the middle. My camera just died. Also, I'm going to be right back as well and get some ice. My water here. Okay. BRB. Okay. You're refilled with ice water. We have equals and plus 55. Adafruit product images are approximately 720p, which looks like where the large size originally stems from and then shrunk. This moved to smaller size was scrimped on CircuitPython.org. Okay, and the last one is delete and backspace on 48. 48. Or backspace and delete, I guess. All right, so that's the first row. So now we're down to the queue. 14. I do think I'll just start a new row. In fact, we could start a new row here as well so that we're sort of broken down. That was 14. Oh, I ran out of... Shoot, I shouldn't have ran myself out of these. $22. I'm half tempted to like write some code that would let me just go through and press each button once and then it would like record it all for me. Truth is, I suspect I would spend longer writing that code and then I would just use it once and then have the same outcome. We could have just brute forced this. As tedious as it is. 23, that's the R, I believe it was, right? Yeah. 16 for the T. 16 and then 24. The next one. T. Y. So that'll be 17. U. 25. $18. Now that we have the pattern, I can finish out a lot of it as well without checking, but knowing my luck, there would be like one that's different somehow. OP 26. Oh, we're not actually ready for that yet. We need our brackets. 19. $27. I just put the wrong one? I just put the wrong one. Thought I noticed that. Then slash pipe is the last one. Just gonna be on what? 20. But that is a special character, so we need a double slash. It's helpful, like C-Grover's touch calibrator, auto key calibrator would be pretty sweet. I think somebody's got one. Jeff, maybe? Somebody's talked about having one. The thing is, too, though, I don't know that it would be adaptable to our weird, not actually a keypad, but kind of pretending to be a keypad. Yeah, I don't know. I would welcome anybody who wants to do it. I'm tempted, but I'm going to resist the temptation. 28. I should be looking, I don't know why, I'm looking at these tiny ones here. You should be looking down here. So that's like shift, which is a weird one. It doesn't really have anything else either. A. 36. I fear with a thing like that too, it's like it would be very easy to accidentally press one key twice or press the wrong key when you didn't mean to. And then either you notice it, which is good, but then you have to start over, or build in some kind of like go back type functionality. Or you don't notice it, which is bad because then when you're typing, randomly one key is actually set differently or something. It should be 30. Find a groovy new song or like 30. That is G 38. Oops. Oh, that was probably loud. My apologies. That's one of the downsides of having the microphone so close, as I occasionally accidentally bonk it. 31. Can't even do it properly manually. Put 2 commas in soft keyboard without noticing until you said something. That's true. I guess just the nice part, though, is that you don't have to, like, you can just delete one. You don't have to go back and redo the whole thing necessarily. Whereas if we build out the, like, auto, just roam around and press each button once or whatever, it's a little more locked into be a lot harder to just make a random edit in the middle. Although I guess once you do it, you could still go make the random edit. You wouldn't just run the whole thing again. You would just edit the resulting code, obviously. And know what I'm talking about. I literally just tried to press the K on the tiny keyboard in order to type the K. We have reached that part in this tedious activity where I'm pressing buttons on the wrong device to make it do the thing. Luckily, we only have one row. I think is that semicolon 33. So that one is actually semicolon and then regular colon and then up. The 41, and that is single quote. Whoops. And then it's actually double quote also, so I'm just going to switch those. And then enter. 34. And enter, I mean, it's like I'm tempted to new line, but I'm also tempted to like enter. Yeah, I think we're going to enter, and then we'll have some other code that will translate that to a new line for the purposes of putting into a string. It's often what you do with keys as you type them. And that is actually the last button this row, which means we are on to row 4. Make sure we don't run out of those. All right, we already have control, so option 0. Found lucky number 0. Lucky number 0. Option. What is, oh, that's like Mac option, maybe? Alt for 8. 8 and 0 being right next to each other is dangerous. They look very similar on this tiny screen. 8, that is Alt. Even better and help you could calibrate it by touching my monitor screen of your stream showing the Cardputer. There you go. Touchscreen through YouTube or Twitch. We have Z, 9 x C to C capital should be 10 E B 11 whoops 4 12. This is one that has 3, so it's actually arrow, and then it's less than, then it's what we are calling left. And we have 5 for period and greater than down. I'm just going to new line it. 13 / question mark, right? Should be 6 is base by itself. All right. Okay. So check keyboard. Not sure how much of this I want to encompass. I'm going to make a input label. I'm going to make it to where when you press keys, if you have set the input label, then it will put the key you pressed into it. So it's kind of like a concept of focus. Maybe we should call it focused label. Let's call it focus label. Focused label. Okay, which means we're gonna want some more stuff. So let's just make a lot of things, like a main group. My word, that is a lot. I want label, I want group, probably want some more things, but I'm not sure yet. It's gonna be a new label, that's gonna be terminal font text empty scale to let's leave it at that. Inpup label. Anchor point. I'm a fan of 0, 0 typically. Put label anchored position of, let's call it 5.5. Let's add that to the main group. Let's show that. Let's make the text something that we can see. And let's see if all that worked. No. Because I am putting this into code Cardputer lib. It is not code.py. Turns out. Did I change this? I don't think so. This was the proposal one. I think I just copy pasted. Let's put Cardputer lib into CodePy. No module. Circup install. Oh, web workflow was merged for Circup too. We could technically use that. I don't like that. That feels very familiar. What is this is Alpha 6. It feels very old. Right? I mean, not very old, but like a week or 2 or 3 or something, right? We're into betas and then RC at this point. To change this so I quit tricking myself with it. I didn't mean to do that. Okay. Well, the one thing I'll say is that this gets us to a point which maybe we should use RC0. So the tricky part now is that installing CircuitPython is not quite as easy as it is on some devices. Yeah, let's take a short detour and I'll explain to you how I got CircuitPython on this. So the person who made this PR, James J. Nadeau, they posted somewhere else online on Reddit, I think it was, some instructions. Yeah, I linked to it up here. They posted some instructions about using the Ultimate Maker Feather S3 page, which is basically what I did. In order to install the bootloader. But I'm not entirely convinced that this... I mean, I think it worked, but I'm not entirely convinced it's useful on this device. because once I installed this bootloader, I can't get it to go to the boot drive. Except for by doing one weird specific thing, which is running this command to make CircuitPython. And I tried to ask about this in the matching dev kit bootloader on. So like, yes, I think maybe. I mean, maybe you can help me figure out one to choose. So I don't know, like, so I mean, I did that, I think. Ultimate Maker S3. So do you know, does this stuff matter to the bootloader? So I'll tell you my theory, my hypothesis. My hypothesis is that I have chosen the Unexpected Maker Feather S3. And I think on that device, in order to get to the UF2 bootloader, I think it's different than a lot of CircuitPython devices. I think it is press reset, and then after you have pressed reset, like press and release reset, and then press and release boot. I think that is the way on this device. The problem is, though, on this Cardputer, when I do that, it goes to safe mode, not UF2 drive. And if I double press reset, which is what a lot of devices are, it just doesn't work. It just comes back to CircuitPython. If I go reset once and then boot once, I go to safe mode. If I go reset twice, I get back to CircuitPython. And then if I go hold boot and then reset, which is like ROM bootloader, that takes me to the ROM bootloader, but it doesn't have the UF2 drive. The only way I have actually gotten this thing to go into the UF2 drive, oh my word. I don't have any idea why all of this stuff is different. Just gonna stash. Pretend none of that stuff happened. The only way I can get it to the UF2 drive so far successfully is by running this make flash, which doesn't, I don't think that's really the intended way to do it. Slower reset twice. I have tried a lot of cadences. I really don't think reset twice is going to do it. I've tried fast, I've tried slow, I've tried really slow, I've tried medium slow, I've tried medium regular, I've tried fast fast, I've tried slow fast, I've tried cold hot, hot cold, medium hot, hot fast. I've tried a lot of double taps, and I don't think we're getting there with a double tap. I think bootloader's mostly tiny USB related, I agree. But if you mean the bin UF2, then yes, the flash RAM size would matter. So I mean about the bootloader. So like my question, what I was getting at is, so I think on this device, the way you get to the bootloader, the UF2 bootloader is different than a lot of Adafruit devices, right? On this device, I think it's single tap reset, then single tap boot. And so I'm wondering if I, instead of this device, if I go instead to Feather S3, like let's say this, and I follow this right here, is there some chance that double tap reset will work, since double tap reset presumably works on this device, I think? But the part that scares me about that is this has 4 megs of flash, 2 megs of PS RAM. This has 16 megs of flash and 8 megs of PS RAM. And then the Cardputer itself actually is what we're really using. And I think it has says 8 megs of flash actually right there, but then it does not say PS RAM anywhere. It doesn't say RAM anywhere. So yeah, I could try loading the Adafruit Feather S3 bootloader and then see if double tap reset works. But I don't know if we'll be like kneecapping it because the flash is different. Feather S3, no PS RAM. This one does have PS RAM there, so there is this one. This has got, this actually say flash? I don't know, 8 megs of flash, okay. Let's have 512 SRAM. Okay, that actually does sound similar. Okay, let's try this one. We'll try it. I'll download this. Gotta use Chrome to do it. My experience bootloader mode initially only brings up COM port and device manager, then online web flasher, then I see CircuitPy. I could put bootloader mode. Drop UF2 on. I think the difference is Feather S3 comes pre-installed with different version of CircuitPython than what would download. Yeah. I mean, it definitely comes different, I think, than the newest one. And then, you know, obviously the Cardputer didn't come with any CircuitPython. But I just don't know the differences between each other. So we'll do that one. So I need a Chrome window. Probably going to break the chat for a second. My apologies. There we go. So that's, where is that web? I don't know the address to this web flasher. Okay, yeah. It's not a super short one necessarily. It's kind of like, I guess it's rememberable, but Adafruit Web Serial ESP tool. Maybe I'll make a short URL that I can try to remember. Okay, so then, so in order to do this, we need to go to the actual ROM bootloader mode, which is hold boot and tap reset. Hold boot, tap reset. Then we can let go boot. We boot up again. I heard the doodaloo in my ear, but this time screen is not there. Drive is not there. This is just like a favorites thing. It's not actually connected right now. So I have no drive right now, no boot, no CircuitPy, nothing. Only what I do have right now is it's connected as serial, which is what this thing is wanting. No PS RAM. Combined. Bookmarked. I should. I'm kind of bad about bookmarks. Bookmarks in theory are a good idea, and I do bookmark stuff sometimes, but I don't find myself going back through them, and then I don't find myself using them as I should, and need to try to get better about bookmarks. Yes, yeah, only showing a COM port. Yeah, that's basically so, and that's expected though. That's like how the ROM bootloader is, as far as I know. So we go combined, and then I think it says press erase, and then press flash after that. It says open that, select that. That was the default. Click connect. We did. Select the port. We did. After that, click erase. Then choose a file. Choose combined. Then click program. I actually chose my file first, but I'll click erase now. That says auto detected, actually. That's interesting. All right, so that says finished. We already chose our file combined, so I'm just going to say program. While that does that, I'm actually going to run to the restroom, though, BRB. I upload the bin first so it's ready and waiting when the erase finishes. Nice, okay, so then that's the same way I did it. Slightly faster than doing it that order. Okay, so that, I think, looks like it finished. Yeah, to run the new firmware, please reset your device. Okay, so at this point, we can reset once. Okay, so I have Feather Boot now, actually, so that's cool. I don't think I got that last time. But I think we're on the right path here. Thank you, whoever that was, Tithe. I think you suggested this one, and I think maybe this one is going to get us to where we want. So let's do that. Let's drop this. So before, what I was finding is it was still comport, and then what I did is I ran basically make flash. I ran this, make board port flash. And then after I ran this like did its thing. It seemed successful. After I ran this, it was waiting for me on a thing pretty similar to what this says. It was basically saying like press reset to run your thing, essentially. And so I pressed reset, and then after I pressed reset, then it came up to the boot drive. Then I copied the UF2, then it came up to CircuitPython. But like this command and then press reset, that was like the only way I could find the boot drive before. Trying to remember what it did immediately after flashing the bootloader last time. I'm pretty sure immediately after flashing the bootloader last time, it was still on a COM port only. It's not a COM port on Linux, but easier to say than TTY ACM. Okay, let's do the release candidate. You guys gave me the confidence to give it a try. Like I was thinking maybe to try a different one and see if that was going to work. I was also kind of scared of it. All right, so that pasted and finished and rebooted. We got a doodaloo, we got a doodaloo. We came up, we're on CircuitPython. Ooh. Oh. Oh, I should have. All right. Oh. Yeah, so for anybody who doesn't necessarily know what just happened, in that process, we deleted all of our files, basically. All the code I was working on just got deleted. It was not very smart of me to not back it up. That was not very smart of me. Luckily, we are using PyCharm, and it looks like, I don't want to start counting my deleted files before I restore them, but it looks like PyCharm is going to save our butts right now. Do I want to revert? I mean, I guess I could revert. Well, I think I just accidentally clicked revert and it went anyway, so no more deciding whether or not I want to revert. It looks like we're reverting, and honestly, it looks like it worked as well, which is pretty sweet. All right, thank you, PyCharm. All right, first things first, let's take a backup of this. Put new bootloader, because basically in my mind I'll know that means the second bootloader that I have put on my device, because I did the unexpected one before. Okay. Oh man, thank goodness. Control Z. Yeah, that's a good, I probably could have done that as well. Well, I would have done each file. Did I not? Yeah, no, I didn't back up the code. Well, I did accidentally back up the code by using PyCharm, but I did not intentionally back up the code, which almost screwed me over pretty bad, but luckily our tool helps us not do stuff like that. Okay, where was I at? So I got this. Is it still okay? Let's try to put back the code. So it was okay. That's fine. We lost our libraries, but I'm fine with that. Let's run that again. Okay, I don't know why it printed that. Oh, that's from before. That must be the bootloader or something. I don't know. We can ignore that. Oh, but it's not connected right now. Okay, I bet you it connected to ACM1. Oh, I didn't mean to do that. Okay, definitely, yeah, okay, it's on ACM1 now. And it is running, and it is showing the label. Okay, so basically, that whole detour, what that means, what that tells us, what just happened is that version of CircuitPython we were on before had a bug. I think it was inside Blit, if I recall correctly. There was some logic in there that's trying to validate the ranges, and it was not correct, and so it was giving us that error. Now that we have a new version of CircuitPython, we're on RC0, which has that bug fixed, which means we're not seeing that bug happen anymore, which means it can put the label on the screen correctly. Okay, and then back to where we were headed. Oh wait, let me check if I can double tap reset now. Or even reset and then boot. Like, I don't necessarily care the exact way to get to it. As long as there is a way. Part of the difficulty, there is an LED, but it's like buried inside here. You can't really see it. And like that, I doubt you're going to be able to see it. You can see it blinking in there. But it, like, that looks like yellow blinks only, right? Like, it's never turning green or red or purple. I think purple is the color I'm actually looking for, right? Isn't that the default thing on a lot of CircuitPython devices? Like, if you reset it when it's purple, that's how you get to bootloader. We don't really get purple, we just get yellow blinks, which is like, I'm pretty sure that's when CircuitPython successfully has booted. Alright, yeah, I don't know. I tried a bunch of different ones. I still am getting nothing. I'll try tap reset and then tap boot. So before, this was getting me to safe mode. Still CircuitPython, but safe mode. Oh, nice. Okay, we got boot now instead. Let me try again just to make sure. I'm just going to reset once. Reset boot. Nice. All right, reset boot does it now. That's so weird though, because I'm pretty sure that's how the unexpected maker is, which is weird because now we flopped back the other way, so it's like, it's crazy. Anyway, it works now. I'm happy about that. Don't actually necessarily care so much about why it works. I mean, part of my brain does, but I'll do my best to make that part of my brain just live with the fact that it does work and not worry too much about it. I doubt the NeoPixel pin matches. Oh. see. Interesting. Theoretically, maybe we could make a... Theoretically, we could maybe make a copy of TinyUSB for this device that puts the NeoPixel on the right pin, and then it could actually show its color. It is weird, though, because it's like, it doesn't seem like double tap actually gets you there. It's like, definitely tap once, and then tap once. And with the old bootloader, that was actually taking me to safe mode consistently. It'll be fine once, yeah, there we go. Okay, so here's, I'm gonna try to do this. We're gonna try to bust this last part out. I don't know if I'll make it, but we're gonna be heading out here before too long. Okay, so we created a label, we're showing a label, so let me make a Cardputer instance. Cardputer. All right, and then we're gonna say Cardputer dot focused label. We changed it to focus. That's gonna be the input label. I'm gonna set this back to nothing now. So focus label is that, and then in the loop we're gonna say we do really need debouncing this time around. I'm gonna probably just go with cheater debouncing, aka time.sleep. But eventually this could have real debouncing. And eventually it will hopefully support the real keypad module, which will make it just come with debouncing. But for now, we are going to cheat. Focus label. So we're going to say inside of here, we want to go check keyboard. It's probably not the right name for that, but whatever. That's going to get the events. And so right here, what we want to do, I mean, we can print it, I guess. There's no harm in printing it, but what we want to do also is add that character to the input label if the input label is actually called focus label is not none. If that's not none, then we want to go focus label dot text plus equals the new character. New char. I like to call it char even though it's character. My Java teacher did not appreciate that, but that's how I say it in my head. Nobody tell her. New char, that's going to be from our lookup thing. Key matrix lookup, that's going to be the key number, which is event.keynumber, which doesn't want to get filled in. That's fine, event key number, matrix, but new char. So we need to deal with shift and all kinds of things. To start with, I'm just going to try to get the letter or character in. So how about to start with, we look up, okay, this is not a tuple. There's one item tuples will get you. This one probably shouldn't have that. I think all of those are tuples now. So we should, let's just take the first thing, and then if it's only a length 1, then we'll treat it as a character. And if not, then right now we're just going to ignore it. So we're going to say if new character, no, if length new character equals 1, then we add it, and we add new char. Yeah, char crew. Yep, I'm definitely on team char for character. Oops. Okay, so one thing that I did not do was my cheater debouncing, but Not sure why. Right, we need to access. Wow, I'm surprised that doesn't give us an error. So basically, right now I'm plus equaling on a focus label text, which is a string, but I'm plus equaling a tuple. And apparently when you plus equal a tuple onto a string, it doesn't crash, but obviously also doesn't do anything particularly useful. A gift from past him not to do this again. Yeah, hopefully we'll remember. I mean, luckily we got saved, which is the good thing. So we should let's just access, I think, 0 for right now. Then eventually we'll, like, if shift is pressed, then access 1, and if function is pressed, then access 2. I'm really surprised that doesn't have an exception, honestly. Nice. Bam. All right, I was going to try to put an exclamation point, but I can't actually exclamation point right now because we didn't do any shift handling. But lowercase letters work, and that is a good start, in my opinion. The cheater debouncing works as well. I didn't really try specifically not to double press, and I didn't end up with any double presses, so basically next we would need to check if, how do we want to do that? We basically need to, like, yeah, it's kind of weird. We need to loop over all the events and check if shift is pressed. And then if, dang, these fire trucks, man. The road I live on is like not quite a main road, but it's like there's a fire station right down the street and around the corner, and the fire trucks like to use this road. And on one of the houses nearby me, there is like a retired fire captain or something like that, and they always, when they drive by, they honk their big fire truck horn out of respect for this retired fire captain guy or whatever person. I don't know their gender, my apology. Yeah, like half the time it scares the crap out of me because it's a fire truck horn and it's kind of right outside my house. And it's not like they don't do it like the whole way down the street, right? So like when the sirens are on, you like hear it from way, far away, and it like gets louder and louder, and you're not like surprised by it. But like with the respect horn, it's like all of a sudden just fire truck horn right outside. Yeah, hopefully that's true. Yeah, okay. I didn't talk. I was busy yapping about fire trucks, but I did find a couple more of those that were not tuples that would have been messed up. I think we got them all now, though. All right, I think we are gonna stop there for today. I will eventually make an issue out of... Did I get my proposal file back? Yeah. I'll eventually make an issue out of this proposal file and see if, if there's interest in having that in the core, if there is preferences or ideas on, like, really, I think the main thing that's kind of like potentially different from the current one is the way it calculates the key number, which I just did the first thing that came to mind, which was effectively multiplying that 0 to 7. Like basically just pretend the shift register doesn't exist at all. the multiplex pins. Just treat it as 8 rows without regard for the fact that it's actually only 3 pins. Because we have a way to check based on the 3 pins which of the 8 rows it is. So we can get ideas on that, and then hopefully either we can find somebody else who is a little more adept in the core to implement it, or maybe get pointed in the right direction a little bit. Like maybe we can get pushed a little bit and try to figure out, because I had a look in the Keypad core code and I kind of went cross-eyed a bit. So I got to maybe have another look now that I've written this. Maybe some of it will make more sense to me, but we'll have to check it out. Yep. Thank you to everyone for watching. I hope everyone has a good rest of your day and a good weekend and all of that. I will be back on Deep Dive this upcoming week. So Friday afternoon, Friday evening at it's 4 p.m. my time, 4 p.m. Central Time, but it's usually billed as 2 p.m. Pacific, which is Scott's time, or 5 p.m. Eastern, which is Adafruit's time zone. So 2 p.m. Pacific, 5 p.m. Eastern, 4 p.m. Central on Friday afternoon will be Deep Dive, and I will be deep diving it this week. And then I'll be back next week on Saturday as well, I believe, at the normal time, 10 a.m. Central Time. So do remember about daylight savings, which is either tonight or was last night. I'm not sure. So if you are in a place that doesn't have daylight savings time happening, then it's going to feel like it's an hour different for you. I don't know which way. I barely even know it from my own way. But check that out. Keep that in mind if you want to watch and you're in a place that doesn't do daylight savings time, is that it will be changing for me. So therefore, the time that I do it at will be changing. Thanks, everybody, and I will see you all later.